Hello everyone, welcome to another tutorial on vector in motion. Today I am going to show you how to identify zero force members in a truss. We analyzed this truss in the previous video and we noticed that out of 13 members, these 5 members are zero force members. So a question arises, if these members are zero force members, that is, they do not carry any load and the internal forces in these members is zero, then why should they be included in the truss? Since they do not carry any load, they must be useless. But that is not the case. Zero force members are used in structures because they increase stability of the truss. They bear the weight of the members and prevent the truss from collapsing. They also carry load under a different loading pattern, and sometimes they are used for improving the aesthetics of the truss. For example, in a stadium roof truss, the designer may add few members to improve the aesthetics. And how do we identify zero force members of a truss? We do it by drawing a free body diagram and carrying out equilibrium analysis. And this is the procedure that we employed in the previous video for identifying these zero force members. But there is another method, which is a visual inspection of the truss and applying certain rules to identify zero force members. So in this video, I am going to cover all the tricks and techniques of identifying zero force members in a truss. Okay? Take a look at this simple truss. I want to show to you that when loading on a truss changes, a zero force member may become a load bearing member. So here in this truss, external force F is acting at joint B, and we wish to analyze the forces acting at joint C. So we draw a free body diagram of C, and there are two forces acting in horizontal and vertical directions. Summation of forces in x direction gives FBC equal to 0, and summation of forces in y direction gives FCD equal to 0. In other words, these two members are zero force members. So we put a cross mark here to indicate that these two are zero force members. Now we change the loading pattern, and let's say the force F, instead of acting at point B, acts at joint C of the truss, like this. So this is the same truss. The external force is now acting at joint C, and we analyze forces acting at joint C. So we draw this free body diagram, and the first equation, sigma Fx equal to 0, gives us FBC equal to F. That is, this member BC is now having a force, internal force of F, and FCD is equal to 0. That is, this member is a zero force member. So with the change in the loading pattern, we notice that this member, a zero force member, has now become a load bearing member, and it goes to prove that a zero force member should not be considered as a redundant member, and it becomes a load bearing member under a different loading pattern, right? Now we move on to learning the rules for identifying zero force members in a truss. So here is the first rule, and that is called a 3201 technique. It is not 3210, but it is 3201. The digit 3 indicates that there are 3 members connected to a joint. The next digit 2 indicates that 2 members out of 3 are collinear. So in this example here, the members BA and AC are collinear. The angle between them is 180 degrees. The 0 digit indicates that there is no external force, either due to external loading or reaction force. There is no external force on joint A. and the last digit 1 indicates that the remaining non-collinear member AD is a zero force member. The first 3 points you can consider as input parameters, and the outcome is given by the last point. When we draw FBD of joint A, the forces would be like this. This force will be equal to this force, that is the force in member AC would be equal to the force in member AB, and this is force in member AD, and summation of forces in this direction will give this force equal to 0. So this is a zero force member, and here in this diagram this appears to be normal to these two members, but if this makes an angle with the collinear members like this, even in such a situation this member will be a zero force member. Suppose this angle is theta, then the force in member AD is in this direction, and when you take its component in the y direction, it will be F AD sine theta, and sine theta is not equal to 0, therefore FAD will be 0. In other words, this member AD would be a zero force member. The collinear members need not be horizontal, they could be at an angle with the horizontal, and in this situation also the force in the member AD would be 0. So in all these 3 cases there are 3 members involved, out of which 2 are collinear. There is no external force acting on the joint, and when these 3 conditions are satisfied, the third member, which is a non-collinear member, will always be a zero force member. Right? This is the second rule, and it says a joint with 2 non-collinear members and no external loads or support reactions would mean both the members are zero force members. Here is the example for rule number 2. There are 2 members BC and CD which are not collinear, and there is no force acting on this joint C, and therefore the conditions of this rule are satisfied, and therefore both these members BC and CD would be zero force members. And now we go to the next rule, rule number 3, which says a joint with 2 non-collinear members is loaded and the external force is collinear with one of the members, then the other member is a zero force member. Example of this rule is here. These are the 2 members which are not collinear. There is a load on this joint, and this load, the external force, is aligned with this member BC, and therefore the other member, that is CD, would be a zero force member. So these 3 rules, 3201 and rule number 2 and 3, will cover all the possibilities of zero force members in a truss. Take a look at this portion of the truss. This diagram shows only the left hand side of the truss, the right hand side is not shown. And while applying rule number 3, you have to be careful about the direction of the external load. So in this particular example, joint A is supported by a roller support which is acting on a plane inclined to horizontal at 45 degrees. So when we draw FBD of the truss and replace this with a reaction force, the force would be like this. The force will make an angle of 45 degrees with the horizontal, because this is 45, this will be 90, so this will be 45 degrees. So the reaction force making an angle of 45 degrees with the horizontal will be aligned with the member AB, because AB also is making an angle of 45 degrees with the horizontal. This is 4 meters, this is 4 meters, so this angle would be 45. And now, since this force is collinear with this member, the member AC would be a zero force member as per rule number 3. The other member is a zero force member. So member AC will be a zero force member. So you have to be careful about the direction of the external force while applying rule number 3. Had it been vertical or in some other direction, then none of these members, AB or AC, would be zero force members. Right? So now, having learnt all the 3 rules, let us apply these rules in a full truss. First, we shall replace these 2 supports with reaction forces. 2 forces replace the pin support here, and a single force GY replace the roller support here. Let's take a look at joint B. The members AB and BC are collinear, and the third member BJ is non-collinear. There is no external force on joint B. Therefore, rule 1 or 3201 is applicable here, and therefore member BJ will be a zero force member. So we put a cross here. Take a look at joint D. The members CD and members DE are not collinear. There is no force acting at joint D, and therefore CD and DE are zero force members. Let's take a look at joint K. CK and KI members are collinear. The third member KM is not collinear. No force on joint K. Therefore KM will be a zero force member. And with similar argument, we can say that member ML is a zero force member, because LE and LI are collinear members, and ML is the third member, and no external force on joint L. Therefore ML is a zero force member. And now at joint M, we have just 3 members. We can ignore these 2 members. CM and ME are collinear. MI is not collinear. No external force on joint M. Therefore, MI is a zero force member. So in totality, we have 6 zero force members. One is BJ, second is CD, third is DE, fourth is KM, fifth is LM, and last one is MI. And we are done. I would like to share my experience with you with regard to the label 3201 for rule number 1. I found this string of digits quite appealing when I was a beginner, because these digits force me to look for 3 members, out of which 2 members are collinear and there is no external force, and then the third member would be a zero force member. So in the beginning, this 3201 was quite helpful in identifying zero force members, but as I practiced more and more problems, I began to look for a visual pattern like T. So this would represent the collinear members, and this would represent third member and no external force on this T. So I would look for this pattern in the truss. And for rule number 2 and 3, I would look for V, inverted V or like this, no external force on this joint. So that would conform to rule number 2. And if there is an external force on these two joints, and if it is aligned with any of these members, then it will qualify for rule number 3. This is an external force and this is a joint, so this member would be a zero force member. Similarly here, if the force is like this, then this member would be a zero force member as per rule number 3. In short, I would look for this kind of a pattern, a T or a V. Okay, so this used to work for me. Maybe it may work for you also. Okay, let's go through one more truss. Here is another truss and we want to identify zero force members in this. So first we replace this roller support with a force like this, AY, and two forces here. This will be IY and IX. These are the two external loads and we have a large number of members here in this truss. Let's first look at joint A. This appears to be a right candidate for rule number 3. We have two members with a joint at A and there is an external force AY which is aligned with member AB, and therefore the member AN would be a zero force member. So this is a zero force member as per rule number 3. Now take a look at joint N. We have two members which are collinear and the third member is non-collinear one, and there is no external force at N. Therefore this force in NM would be same as AN and the member NC would be a zero force member. So this would be a zero force member, and since this is a zero force member, NM also would be a zero force member. Now let's look at pin number C. This again qualifies for rule number 1 or 3201. There are three members, CL, BC and CD. This is a zero force member, so we can ignore it. BC and CD are collinear. Therefore, CL will be a zero force member. Let's take a look at pin I. Here we had a pin support, therefore we replace that with two forces, IY and IX. But we notice that there are no horizontal forces on the entire truss. Therefore, IX would be 0. There is only one force acting at joint I, and that is in a vertical direction. So as per rule number 3, these two members are not collinear. There is an external force at the joint and that is aligned with the member HI. Therefore, the member JI would be a zero force member. And once we ignore this member, then we find that KJ and GJ, this member and this member, also qualify for rule number 3. We have two members KJ and GJ which are not collinear, and an external force of Q is aligned with the member GJ. Therefore, KJ would be a zero force member. Okay. Look at pin E. Again, these two members are collinear. There is no external force on joint E, and here is the member, third member, which is at an angle to these two members. Therefore, this member EL will also be a zero force member. So in all there are 7 members which are zero force members. 1, 2, 3, 4, 5, 6, 7. So we are done, and in case you have any question, please put them in the comment section below and I'll be too glad to respond to them. In case you like this video, please give your thumbs up, share it with your friends, and in case you are new to the channel, please do subscribe. Thanks for watching and see you in the next video.